Okay. Hopefully you guys can hear me okay, yeah? Mic's on? All right, very good. Good afternoon. I'm Dave Salvatore with NVIDIA. Welcome to this session. I'm very aware of the fact that I'm the only thing standing between you, dinner, drinks, and parties, so I'll try and make this interesting. Anyways, I want to talk to you today about the NVIDIA AI platform and our collaboration with AWS to bring that to you on the AWS platform. So I want to start off with, we've all obviously been hearing tons about generative AI. It's been obviously in the news quite a bit. We all sort of talked about, what we had, the chat GPT moment, as it's known, which is suddenly generative AI didn't just come to our whole industry. It came to the whole world, right? Suddenly it was something that everyone was talking about. Your uncle at dinner who knows nothing about tech suddenly said, tell me about this chat GPT thing, right? So clearly, it is on the radar now, and we've seen some amazing things from generative AI already, and we're really in still just the very early innings of this thing. So enterprises are now figuring out, okay, we get it. Generative AI has a lot of potential. How can we use it? So there's a lot of experimentation. Innovation, experimentation, those two things go hand in hand, right? Which also means there's going to be a lot of things tried, not all of which work, right? A lot of experimentation, and then finally, after POCs and kind of, shaking out, the issues and potential bugs there may be, it goes to production and it goes live, right? It is a lot of you know who are developers. Quick show of hands, who are my developers? Okay, we've got a pretty good number, cool. So as you guys know better than most, building AI applications is really hard, right? And so one of the things I'm going to talk to you about during these next 60 minutes is some of the ways we're helping to make it easier to deploy these models on the AWS platform. So generative AI, the other big question, of course, and it's the right question to ask about any new technology, which is, okay, new shiny technology. This looks really cool, huge potential. What can it actually do for my business? What can it actually do to bring business value, help me solve business problems? Because at the end of the day, it shouldn't be technology for its own sake, right? Those of us who are in the technology sector, of course, love technology and love learning about technology, but at the end of the day, it does need to solve customer problems, right? So we've just got a couple of three things here listed in terms of some things that can help deliver, operational efficiency being a big one. That ability to also do things like get people the help you need. For instance, I'm staying over at the Cosmopolitan Hotel. They now have an AI agent that you can text to get answers from. So yeah, you can call the front desk and talk to someone, which is all well and good, but they've got this pretty cool generative AI chatbot agent that you can talk to get information, and they've even given it kind of this almost snarky voice. So they're just an example of how generative AI, it's finding its ways into all kinds of industries. And that kind of relates to the improved customer experience piece, right? Of finding ways to get customers help faster. As businesses scale and grow, that ability to make sure your customers are getting taken care of becomes a growing challenge, right? And the customer support centers may or may not grow as the business grows. The customer base grows, the problems maybe get more complex. And if customer sort of care starts to kind of fall off, that can usually lead to not good things up the road. And then finally, differentiate, right? We talk about, FOMO, fear of missing out is certainly an aspect of any new technology in the industry. But there's also, what are the opportunities, right? Never mind, the fact that, hey, maybe won't do this. What if I do it? What advantages will it give me, right? And so these are some of the ways that particularly CIOs and CTOs and technologists are thinking about how to deploy Gen AI, right? So the thing of it is, and this is the really great part, Gen AI can solve problems in almost any industry, right? And I'm not going to read this whole slide to you, but you get the sense of just the breadth of challenges and issues that Gen AI can help accelerate, ameliorate, and otherwise, make better, right? Or allow us to gain new insights from data, allow us to take better care of our customers, and allow us to operate more efficiently, right? And then, of course, acceleration and performance, which I'll talk about in a few minutes, are key to all of this, right? And if you don't have the requisite performance, a lot of these services are not going to be compelling and people will not use them. And we'll talk more about that in a few minutes. So another piece, though, and this is something near and dear to AWS's heart, it's something near and dear to us as well, is sustainability, right? This demand that we see for generative AI has just so just ramped the amount of demand we have for compute in the cloud, on-prem, everywhere, right? And so with that come additional power and energy requirements. But one of the things that we're doing, and in particular I'll point to our Blackwell architecture, which I'll talk more about in a few minutes, are finding ways to make the architecture not only more performant, but more efficient. This is hugely important. Because at the end of the day, we're going to, when we talk about rack power density, when we talk about the overall data, power consumption of a given data center, it's very, very important to not just look at that number. You also have to look at how much performance are we getting out of that power budget, out of that energy consumed. And this is where GPUs in particular are extraordinarily efficient in terms of how much performance they're delivering in any given power envelope. And then you can see sort of on the right-hand side of this slide, what's driving that has been the growth of the models, right? And there's, again, as I talked about with innovation, there's experimentation. There's a lot of work around finding ways to help reduce cost, right? You heard Matt talk this morning about something, a new service that AWS is going to offer called distillation, right? Where they're going to try and take large language models and turn that essentially into a smaller language model that can be deployed more readily, use less infrastructure, and reduce cost. So there's a lot of different things being tried. There's also work being done around using smaller language models of around 7 to 10 billion parameters, but then running many more tokens through that during the training process, right? So it's a way to make a smaller model smarter and get a quality of responses that it can be comparable to larger models that are, say, more in that, maybe say 70 billion parameter range. That said, the trend line around the models getting bigger does continue. You don't have to look any further than Llama 3 with 405 billion parameters. And then you have additional things coming along, and I'll talk about some of these towards the end of the talk around and these got talked about in the keynote this morning as well, around agentic, around multimodal. These are also going to be, the possibilities with these things are really exciting, but it's also going to drive a lot of requirement for compute. So and this is just more for maybe sort of what the business folks in the room, as you think about how do you want to go to the cloud, there are some really good reasons to come into the cloud, First of all, one of the great things, of course, with the cloud, and you're here, so I think you guys are kind of, get this, I won't dwell on it too much, but the great thing about the cloud, of course, is you only use the compute you need, and when you don't need it, you basically give it back to the cloud provider, and you are no longer consuming that energy or having that cost, right? So it's very, and it's as the name that AWS loves to use around elastic suggests, it's very much elastic compute, right? So I won't spend too much time on this one. This is more for exec audiences. So our platform, and it's important to understand that NVIDIA is a platform company. This is a really important concept because there is a tendency to think of NVIDIA as, yeah, they make those GPU things, right? And we do. And that is our heritage. We come from a visual computing heritage, when the company was formed about 30 years ago. That said, GPUs do so much more than that, right? And more to the point, to build these platforms, to enable generative AI, it takes an entire platform. I'm going to talk to you a bit more about that. But one of the really critical pieces, of course, enabling this broad swath of usages, right? It's not just about being performant on a couple of things. It's important to be performant across as many things as you can be. So that versatility, for any of the infrastructure managers in the room, one of their favorite words, and it's a funny sounding word, but they talk about fungibility, right? Fungibility meaning that it's a resource, a compute resource that can be used for a wide variety of things. It basically means versatile. That's all it really means. And the point being is that the more performant you are on the broader number of use cases, what that really means is that that resource is more versatile and can solve more problems for you and for your customers. And I'll have more to say on this in a moment. So as we think about the NVIDIA AWS partnership, it starts with our infrastructure. It starts with our GPUs. And AWS has an amazing array of NVIDIA GPU instances available today. And you heard get announced this morning 2 more, which were going to be the H200 on the P5EN instance, which got announced. It's gone GA this morning. And then they also announced this morning, of course, the Blackwell-based P6 instances, which will be coming next year, right? And so you heard Matt talk about those this morning. In addition, we have some of our own services you see listed here, right? And I'll talk a little bit more about each of these, the DGX Cloud, NVIDIA Enterprise, NVIDIA NIM, and NVIDIA Omniverse, right? So that already is a lot in terms of the scope of our partnership. But again, it goes beyond that. It goes way beyond that. We do a ton of integration up the stack into AWS services. One of the factoids I like to kind of throw out there is the fact that NVIDIA has twice as many software engineers as hardware engineers. And that choice is very purposeful. We do that because that's what it takes to make this platform do what it does, right? It takes the form of development relationship managers. It takes the form of what we call our dev techs, our system architects. And just a huge group of engineering teams inside of NVIDIA who are working every day to optimize performance and get more performance out of today's models and get tomorrow's models ready to be deployed. So we kind of called out there in the middle of the slide, some of the integrations that we have in places like SageMaker, in Bracket, in Bedrock, and a number of other places you see listed out here, including things like EMR, for instance, for data processing, right? And then on the right-hand side, our customers who are using our technology on the AWS platform. This includes well-known, Fortune 500 enterprises, as well as a huge number of startups, some of whom we have listed there. And then, of course, we work with ISVs, we work with GSIs, global system integrators, as well as solution development providers, SDPs, you see down there at the bottom. So there's this whole array of teams that work together to make our platform as sort of broadly usable and available on the AWS cloud platform. So we have a couple of announcements I want to quickly just step through. These were in our own blog on NVIDIA.com. DGX Cloud is now available on AWS, and we're very excited to see that. This is a great service that I'll tell you more about in just a few minutes. Also with Greengrass IoT, this is AWS's solution for at the edge and for Internet of Things devices. Will now be integrated with our Jetson platform, which is a small platform about that big on the whole thing. Physical AI with robotic simulation, this is using our Isaac Sim development environment, now available on AWS. CUDA-Q, this is now being integrated into AWS Bracket for quantum computing. This is our library to help accelerate that. We do amazing quantum simulation on our GPUs, and we have a number of libraries that help make that happen. And CUDA-Q is now being brought into Bracket to accelerate quantum in that environment. And then lastly, our Triton Inference Server is now going to be available in what's called SageMaker Container Caching, which is, again, a technology to help kind of make it more easy to sort of recall containers and use them. Our inference serving software is open source, and it can be tweaked any way you want to use it, because that's what open source software lets you do. But it's very performant, very versatile. It can host a wide variety of networks. It's highly integrated into Kubernetes and can be run on the Elastic Kubernetes service. So a lot of versatility there. So again, nice kind of array of announcements here. This, of course, in addition to the announcement around both the H200 instance, the P5 EN, as well as the P6 Blackwell instance, which were announced this morning. So a couple more things about the platform. We talked about sustainability and efficiency, right? And so part of what we're trying to do here is continue to grow performance in a way that is sustainable. So in other words, we can't just do performance for its own sake, right? We need to think about other ways to get performance in a way that is efficient. So as an example, in the Blackwell platform, one of the things that we're going to is liquid cooling, as an example. So our GB200 NVL72, and I'll talk more about that in a moment, is going to be using liquid cooling, which is actually going to be a really interesting and more efficient way to cool the data center and to cool those platforms. And a bit more on that in a few minutes. But in terms of consumption and thinking about how do we reduce power, right? If you look at that far right figure of 20 terawatt hours of energy saved, this comes back to the fact that GPUs, in fact, are quite energy efficient. Which is, I know, a little bit counterintuitive, because you may look at things like our TDP and go, but yeah, isn't your TDP really high? And the answer is our TDPs are pretty significant. But with that said, you have to look at both power and energy, right? So power is, you can think of power as being sort of on the y-axis, and you can think of time as on the x-axis, right? So energy is power over time. And you take the area under the curve to figure out how much energy you've used. And so even though the power may appear to be higher, if you're getting the work done 5 to 10 times faster, when you look at the energy consumed to get that work done, it's actually much less energy. In addition, the additional performance allows you to service more customers simultaneously, use less infrastructure, build more sophisticated models. There's a whole bunch of ways you can use that benefit, depending on the kinds of applications you're looking to build, right? So again, it's that blend of efficiency and performance that we continue to drive in our platforms. And just a little bit more on cost savings. These are just a couple of examples using things like our TensorRT LLM software, which is used for accelerating LLMs for inference, and then reducing TCO as well. So right, this is just sort of illustrating the point that additional performance helps reduce TCO. It also helps reduce energy consumption, which is something that is still kind of certainly top of mind for AWS and us, and for a lot of developers out there, for obvious reasons. So another thing I want to just touch on here is the Hopper platform. So this is what powers our H100 and H200 instances here on AWS, right? And we continue to just see phenomenal performance coming from this product, right? And so again, this is available today, something you can use today. And we continue to get more performance from that platform. That architecture has been in market now for about 2 years. And we still, in just the last 6 months, managed to get another 30% of performance on the training side of the MLPerf industry standard benchmark, right? We've also been able to run at really impressive scale of over 11,600 GPUs. And we have line of sight to run on many more in the very near term future. So when we think about at scale, when we think about agentic, when we think about multimodal, the things that are really going to drive that need for a lot of performance, those are going to be at scale problems. Even if you're just fine tuning a network that's already been pre-trained, that is still an at scale problem. And increasingly, we're going to see that inference will ultimately start to become a multi-GPU, multi-node, basically at scale type of a problem to deliver great user experiences using these new technologies, right? So let me just keep going. So again, similar comment here about getting faster. This just shows you sort of the up to 27% over the course of just 6 months. And this is a result of that ongoing optimization work I talked about a few minutes ago that all those software teams are doing. This is something we're doing every day. Every day we are looking to find ways to get more performance from our platform, even once it's been in market, in this case for almost 2 years. And so in any given generation of architecture, we typically get about another 2 to 2.5x more performance from that architecture over the course of its product life cycle, right? And so if you think about that as developers, that to you is essentially free performance, right? Which takes the form of reduced TCO, ability to train models faster, get to market faster, and again, potentially use less infra, which can ultimately help you reduce your deployment costs. And then also another important piece of the platform is NVSwitch, right? NVSwitch is basically our switching chip that sits on our NVLink fabric that allows all-to-all GPU communication within the node. Today it's in the node. I'll talk more about that in Blackwell. So up to 8 GPUs can be talking to each other over this fabric. It's all-to-all, and they can all have simultaneous 900 gigabyte per second connections to talk to each other. So if you think about the work involved in training, which is very chatty between the GPUs in terms of things like updating weights and all reduces and all gathers, that takes the form of a lot of inter-GPU communication, which NVLink helps to accelerate. And we sort of illustrate that point here. And by the way, what you're seeing here, this is actually on real-time inference. This isn't even training. So I was talking earlier about multi-GPU becoming increasingly a thing we're going to see on the inference side of the house. This sort of illustrates that point, that we're seeing up to 50% more performance for real-time LLM inference, even on the inference side. And we're going to take that to a whole nother level in Blackwell, which I'll get to here in just a moment. So a couple of other just comments around, again, the ongoing work we do across the different LLMs, right? We've got a number of them here, not the least of which is kind of on the far right there. Continuing ongoing work on 405B, which some of you may be working with. This is by far the most demanding of the LLMs out there for a couple of reasons. Just its sheer size, the fact that it supports multimodal, and the fact that it supports very long sequence lengths. All of these things come together to make it a very, very demanding workload. So we continue to work on that to optimize it and have made really good progress on that, and that work is, of course, ongoing. So now to talk about the platform a little bit more. I've been using this word platform quite a bit. Well, what do I mean by that? Well, what I mean is that it really is, we cover the whole stack, end to end, top to bottom, right? So if you look at this picture, what you're seeing here is the Blackwell sort of platform. That's the Blackwell rack you see there in the middle of the slide. You see to the right of it what we kind of call the sidecar, which is the liquid cooling unit. And I touched on liquid cooling a moment ago, and I want to just touch on that again, because one of the modalities of liquid cooling, there's a bunch of different ways to do liquid cooling, right? One of them, however, is what we call warm water direct liquid cooling. And what this means is that rather than using a chiller, which you can think of as being like a compressor you have on your refrigerator or your air conditioner, you actually just use ambient air, and basically as the water or liquid is cycled through, it basically comes through, carries heat away, cools somewhat down to about a warmish temperature, I don't know the exact number, and then is cycled back through to cool again. So in other words, there's no chiller in that loop. So by taking the chiller out of the equation, by taking fans out of the equation, this becomes a very efficient way to cool your data center products. in such a way that you are reducing energy while delivering this amazing performance. Not to mention, for those of you who've actually walked inside a large-scale data center, the overall noise level is going to come down substantially because the fan noise in some of these data centers can be pretty intense. Another thing to note is across the bottom there, you see a whole family of chips, right? Yes, we make GPUs. We make amazing GPUs. We also make a pretty impressive CPU called Grace today, and Vera will be our next generation CPU. We also make our NVLink switch chips. Today, and we're on, I believe today is 4th generation. We'll be going to 5th generation in Blackwell. And then we have these different compute trays, or different trays you should see there, one for compute, one for NV switch, and then a couple for the different options on networking, whether that's Ethernet or InfiniBand. We offer both, and depending on what customers want to use. But the other really important piece is what goes across the top, right? I talked about software. I talked about the fact that we have twice as many software engineers as hardware engineers. We build all these software layers, including CUDA and CUDA-X, but also the thing we have is hundreds of libraries that are kind of purpose-built and specific to enable you to do the development you need to do, right? So there's this whole collection of technologies that come together to form our platform that are necessary to make the platform as versatile and as performant as it is. And then we have some higher level services like NIM and Blueprint agents, which I'll talk more about in just a moment, to sort of round that out, our kind of, some of our latest service-based offerings that we're currently bringing to the market and are available on AWS. So I've mentioned Blackwell a few times, and again, a lot of really interesting technology in Blackwell. You've seen a number of maybe social media posts about some of our partners getting ready to bring Blackwell to market. AWS will be bringing it to market early next year. You see on the right there some of the key technologies in Blackwell. One of those, by the way, is a more efficient tensor core. Tensor cores are basically can be thought of as those are kind of our very purpose-built math engines for doing matrix multiplies at a whole variety of precisions. We're actually adding FP6 and FP4 now in terms of precisions that are available in the Blackwell platform, enhanced security, as well as a RAS engine to help for uptime, to keep closer to 24/7 uptime, and then a compression engine because much of the data that you're ingesting, particularly at the front end of machine learning processes, is compressed. And so we have an ability to help decompress that data much more quickly by having a decompression engine built into the GPU. So I talked about NV switch previously. I'll just do a quick touch on this. The main takeaway here is that we're actually going to 2x the amount of bandwidth now that we'll have in terms of inter-GPU communication. We're going to go from 900 gigabytes a second for inter-GPU comms to 1.8 terabytes, right? So just an amazing amount of bandwidth to allow these GPUs to talk to each other, which is going to have influence not only on training, but also on inference. And how that shows up is we've been actually submitting Blackwell to the MLPerf benchmark, both for inference and training. And so in this case, this is for the training side of things. We're able to run every benchmark and actually set new per GPU records with Blackwell in the most recent round, which dropped last month in the middle of November. And then we saw up to 2.2x more performance versus Hopper on LLM workloads, right? So we're pleased with that. These are kind of what I'll call the initial performance upsides. Much more to come. I mean, we're still sort of in the process of getting all of our software tuned and dialed in. So more to come in this department, but this was a really good first showing for Blackwell. And again, more to come in future rounds of MLPerf. And then in a similar vein, right before that, we had done inference. And there we saw up to 4x more performance. And again, I think this was on Llama 270B, over 10,700 tokens per second. So, we continue to deliver great performance with Blackwell as we have in the Hopper generation. And again, more to come there as we continue to get our software dialed in and get the platforms brought to market. So, we are sometimes guilty of, fixating a little on performance here at NVIDIA, and we do that for a simple reason, because performance drives ROI, right? At the end of the day, performance is the benefit that allows you to do any number of things. You can either reduce your infrastructure on existing workloads, you can build more robust, sophisticated workloads, you can build larger scale workloads. It allows a great many things, but primarily it is around, ultimately the business problem that it solves is delivering more ROI, for both training and inference, right? So, and again, this one's a little bit more for kind of folks on kind of more the business side of things who are thinking about building apps for the enterprise. This just sort of shows kind of Think of it as a high-level flow diagram for developers. This is probably pretty straightforward, but it does sort of illustrate that, we have software in our overall platform to help with every step of this process. This is why I say we are end-to-end, full stack end-to-end. From the beginning to deployment, we have the various software technologies you need to be able to build your applications and deploy them. And things like NIM help you do that even more quickly, which I will touch a bit more on in a moment. So for developers and for organizations who are maybe relatively new to the generative AI and deep learning space, some frankly are going to need some help and some support. So we have a program called NVIDIA AI Enterprise, which basically gives customers access to monthly containerized software that's been fully security scanned and updated, and then also has white glove support from NVIDIA. So in other words, you have direct support from NVIDIA to help you build and deploy your applications. So it's a combination of things. And for a lot of organizations, particularly those who, and the developers can probably attest to this, open source software is a wonderful thing. And it has enabled so much of what we have done in the AI and generative AI spaces. That said, when it comes time for support, because it's open source software, it may or may not have an organization actually supporting it. Whereas the open source software that's rolled into our containers, in the case of these NVIDIA containers for AI Enterprise, is supported by NVIDIA. So if you're having an issue there, that's something we'll be able to help you with. So this is a terrific program, particularly for those organizations who maybe don't have the deep expertise in AI just yet, and who are looking to kind of bootstrap their efforts and get moving more quickly. So I may have mentioned NIM once or twice as we've been moving through the talk. And so NIM stands for NVIDIA Inference Microservices, right? And these are containerized, mostly large language models, but also some other use cases you see listed out here that are more readily deployed. Some of these can be deployed with a couple of mouse clicks in a matter of a few minutes, right? And so this allows developers, again, maybe some developers who are not necessarily as experienced with Gen AI, to be able to build applications more quickly and deploy them more quickly. Because getting the app deployed is super important. Time to market matters, right? Because once the app is deployed and delivering insight, that's the return on investment, right? The training, the fine tuning, the getting it ready to deploy, the testing, the shakedowns that you have to do to make sure that everything's ready to rock and roll, all critical parts of the path. But that's the investment you make to get the return on investment, which is the deployed application, right? So NIM really helps get those apps deployed more quickly. And then we take it a step further with something we're calling NVIDIA Blueprints, or Blueprints Agents, is I believe now the new term. These are very use case specific implementations of specific models that, again, have been containerized and are ready to deploy with a few mouse clicks. And these are also, by the way, NIM and NIM Blueprints, or Blueprints Agents, I should say, are readily available now on the AWS platform through their marketplace. So these is yet another way to allow developers to move more quickly, deploy more quickly, and get things up and running, in particular to kind of prove the viability of AI to those who are maybe looking to figure out, hey, what's the business value of AI? This helps you get things up and running more quickly, to show that return on investment, to show that possibility, to get more projects green-lighted around generative AI. Another interesting technology we make available is called Omniverse. This is actually a really cool technology that kind of blends both where we are today with some of our visual computing heritage, right? So again, as I mentioned, we come from the world of 3D acceleration. It started a lot with gaming, on the PCs, consoles, handhelds. And then, as we developed CUDA, as we developed data center products, and then, things like around scientific simulation and HPC, and then ultimately, when AI really kind of took off in about 2012, that sort of initial, big bang of AI, as we like to call it, happened on NVIDIA GPUs with AlexNet, right? But what Omniverse does is it brings together what we call physically informed neural networks. Basically, networks and environments that can obey the laws of real-world physics, along with the ability to visualize and collaborate in a virtual space. So some of the examples are things like digital twinning of things like factories or warehouses, where those things can be basically built and modeled in such a way that you can initially build them, because as you can appreciate, those types of assets are very expensive to build. And once they're built and everything is sort of put in place, it's also expensive to have to try and reorganize them and move things around. Because not only do you have to do all the moving, you actually have to take the resource offline to do it, right? What digital twinning allows you to do is to basically build that factory before you really build that factory. In other words, or build that warehouse, and then be able to play with the objects inside that warehouse in a way that obeys laws of physics. You can set up, basically virtualized robots for things like, for as an example, robots that might move pallets around, as an example, inside a warehouse. And you can model all this. You can model pathways. You can model for safety. There's a huge amount of collaborative modeling that can be done in the Omniverse environment. And again, this is available on AWS now. So this is a very interesting platform for companies looking to bring together both AI as well as kind of some of these virtual collaborative environments for robotics, and again, those environments that need to kind of obey laws of physics so that you can do that modeling. So just a couple of customer examples I'll take you through real quickly. Perplexity makes a really interesting large language based chatbot that we actually use at NVIDIA. We run it and use it somewhat internally at NVIDIA. We play with all of them, obviously, but Perplexity is one that we've used a fair amount. And so they continue to use our technology on the AWS platform. And they were looking to increase their accuracy, basically, of the models. As you guys know, accuracy is hugely important. This is one of the things that makes building AI applications, especially Gen AI and LLM-based applications, difficult, is there's a number of basically competing constraints that you have to solve for. Yes, you want performance, you want throughput, but it has to be accurate. You want low latency, which also usually kind of tugs directly at throughput, as an example. Then there's different kinds of latency, right? There's inter-token latency, there's time to first token. And so solving for all of these things in a way that delivers a great customer experience while managing deployment costs, it is not trivial, right? So Perplexity kind of looked at this and said, hey, maybe we can use NVIDIA technology as part of our overall workflow. And they were able to lower costs by about 4x by switching their external inference serving over to the NVIDIA platform. So that's just one example of a pretty well-known provider of LLMs, who's seen pretty significant benefit on the NVIDIA platform. And a lot of the LLM platforms are, of course, running on NVIDIA, but this is just a good example. And then this one is interesting. This is Alpha Bio. This is a company that's doing drug discovery and sort of molecular modeling. And they were able to use our technology to see a 10x increase in their predictions. So this is, again, massive. If you think about, a lot of molecular dynamics and drug discovery involves modeling molecular interaction. You introduce, a drug candidate, or some type of a would-be drug substance to a molecule, and you want to be able to model that, right? And you want to be able to see what happens. And that molecular dynamics piece can take a very long time. But using AI, this has been a really interesting marriage of scientific simulation and AI, whereby using some of the data you already have gathered at very high precisions like FP64 and using that as a data set to train your model, you can actually then do trials much more quickly to identify interesting candidate substances, which you can then do at your higher orders of precision to really go in and do deep modeling of them. So it's just a way to help dramatically accelerate time to market for drug discovery. And if we think about that, that has a lot of implications. It has obviously societal benefit implications of getting better medicines into the hands of people who need them. And it has obvious benefits for helping companies developing those drugs move through that drug sort of trialing process more quickly and get to the places where they can start doing clinical trials and working through FDA approvals and things like that to speed those drugs to market. Right? So a quick touch on DGX Cloud. As I've said, look, building AI applications is not easy, right? And sometimes people will do the POCs, will do the proof of concept type efforts, and ultimately they may or may not see the benefit that they hope they would, right? And these are some of the reasons why. This is from a recent study. This was done, I believe, was this Gartner? No, this is IDC, sorry. So again, it can be the fact that maybe developers within that organization don't have a lot of experience with AI yet. It could be a matter of cost versus our ROI objectives, or it could be a matter of, hey, we just don't have the infrastructure, where obviously cloud has a role to play in helping solve for that. So, these things are sort of some of the barriers and challenges to actually getting, generative AI built and deployed. And DGX Cloud is here to help with that process. So DGX Cloud is available now on AWS and basically gives you 24/7, basically your own infrastructure in the cloud that is yours. It is not preemptible. In other words, once you've rented it for the period of time, however, 1 month, several months, however many months, it is basically yours to do with as you see fit. And for a lot of organizations, that involves training. Whether that's pre-training or fine-tuning, they want to have that resource that they know is theirs, and that when they're done with it, they can basically, again, sort of let it go and no longer have to pay for it. It also helps them, of course, not have to deal with some of the upfront CapEx costs of trying to build these things on-prem. Again, another gating factor there might be not only do they not have the needed infrastructure, they may not have the expertise to put those systems in their data centers yet, right? So this is where DGX Cloud can very much help you in that regard. So this just sort of is a flow diagram that just sort of gives you an idea of how we, working with AWS, we can carry you through the whole development process. I think I've covered that, so I don't think I'll dwell too much on this one. I do want to touch briefly on Project Ceiba. This is a really interesting thing we're working on with AWS. This is going to be a Blackwell-based system of about 20,700 Blackwell GPUs, which is going to just represent huge scale. And it's going to be something that NVIDIA researchers are going to be using to do our own research around next generation generative AI models, agentic models, multimodal models, and beyond, right? And we're looking to use that to really, again, work on some of our own models and frameworks, which then roll their way into the platform. And in some cases, we'll be using it as well to do performance characterization on cutting-edge community models to make sure that they're running very well on the Blackwell platform. As I mentioned, the Blackwell platform does have some really significant next-level aspects to it versus what we've done previously, not the least of which is 72 of those Blackwell GPUs all talk to each other over our NVLink fabric at 1.8 terabytes per second for every connection. It's all-to-all, right? So this is going to be a really interesting platform. You can see some of the figures here, 414 exaflops, which is just a mind-blowing amount of compute, and just huge amounts of networking as well. So, I mean, this is going to be a really robust platform that we'll be using to drive some of our own research, and it just is a great collaborative effort that we're working on with AWS. And then AWS themselves, of course, continues to build out and be at scale. So there's Project Ceiba. There's also going to be their own EC2 instances that they're looking to deliver, as well as DGX Cloud. And all of these things will, over time, be offered as well on Blackwell, right? So, the scale of things, we just continue to work with AWS to scale their capabilities with our technologies to enable those next generation, those next level usages and applications for Gen AI. So some of the what's next, and I've kind of stolen my own thunder a little bit here. The models continue to get smarter. That's not just about size, it's also about the sophistication of what each layer is doing, right? The models and the techniques and the algorithmic techniques continue to evolve and get innovated upon, right? We've been doing a lot with transformer-based model architecture now for the last several years. And that continues to be a very effective architecture, but there will be architectures beyond transformer, right? And we have a platform that is sufficiently versatile and performant to be the place where a lot of that, what I'll call early research work around bringing those next generation model architectures to the world will happen on our platforms, right? Visual language models and multimodal kind of go hand in hand, that ability to use both images and text and video and things like PDFs, for instance, that we have just trillions of PDFs in the world, and the ability to use those as data that can not only be used to train the model, but then also be run through the model for inference. And if you think about the implications there for, again, multimodal and agentic, those are going to be some really interesting use cases in terms of being able to kind of comb through just huge volumes of data and then do things like chain of thought reasoning and other sort of more sophisticated tasks, in the agentic space, to find new insights from those types of content, right? So I'm coming to the end here. There will be some time for questions if you have any. We have a microphone set up here, and so if you just bear with me when I get to the end of the talk, I'll be happy to entertain some questions. Just a quick touch on our roadmap. We are now on a one-year cadence with delivering new architectures. We've been on Hopper now, and now we're about to come, Blackwell is now coming online like this year, and then really coming online early next year. Beyond that, we have Blackwell Ultra, where we're going to be delivering both more memory as well as even more compute capabilities. Beyond that, we have Rubin, and then Rubin Ultra. So, I mean, we are on just this pace to continue to deliver these new architectures and these new platforms and all the requisite software and NV switches and networking and CPUs that go with it. You see the networking and CPU pieces listed here as well. Today we're on Grace. Over time that will become Vera. That will be our next generation ARM-based CPU that will help power our platforms. And then of course we continue to build out our networking processors both for our smart NICs as well as for our top-of-rack switches and continue to innovate there as well. So we really are thinking about building at the data center scale. And everything we do, I mean, it starts from the chip, but it goes all the way out to the data center. And we think about every step of that. And not only do we build, of course, our GPUs and our networking chips and our CPUs, we then build, our own reference servers we put them into, which we call HGX, and we also offer our own branded servers called DGX. And then from there, we also even build supercomputers to really shake them down and make sure that things run well at scale. We then take those learnings and bring those into something we call MGX, which are our reference server designs that ODMs, OEMs, cloud providers, partners can use to then build their servers and get them to market faster. So again, really thinking about platform at, again, data center scale. And so with that, again, just to reiterate, we have a phenomenal collaboration with AWS, a long-standing collaboration. It goes back to the very first GPUs in the cloud about 14 years ago. We'd very much encourage you to come by and check out our booth and talk with some of our topic experts there. We have a bunch of cool demos to show you and just some other fun stuff you might want to check out. And if you have more interest in learning about partnership, you can scan that QR code and that will take you to our partner pages on NVIDIA.com. So with that, I thank you guys for sticking it out with me here at the end of the day. I'm sure it's been a long day for you all, but at this point, if there are any questions, be happy to answer those.